All right, just a quick look at the memo of the third weekly test for my section at least. The first, we're dealing with double bond forming reactions. The first two questions were all about Wittig reactions. Over here, if we look at this, we see that in the product, an aldehyde over here in the product, we must have formed this carbon-carbon double bond. Must have been through a Wittig reaction. It is Z selective, all right? We've got the cis double bond, so it must be an unstabilized ylid. That should be easy enough. We've got 1, 2, 3 carbon atoms and then the aromatic ring. So we're wanting to have something, so 1, 2, 3 carbon atoms and then the aromatic ring. And then a lot of you made a very simple mistake. You put the triphenylphosphine directly over there, but of course then you eliminate a carbon atom. Be careful about doing that. It's a very simple mistake to make and easy one at that. All right, this would be the Wittig reagent, obviously with a counter ion, Br minus. But we need to deprotonate over there. A typical base that we could have used was Bewley, could have used other bases as well, Grignard reagents, a number of you used and things like that. But yeah, all of that would have worked and I would have given you 2 marks. I marked this fairly lightly. This question over here, it's important to recognize that obviously this is the new carbon-carbon bond that was formed, but in order to do the Wittig reaction we needed to oxidize this alcohol up to the aldehyde. There are a number of different options. PCC would have been one that would have been acceptable, pyridinium chlorochromate, or we could have used Swern oxidation. Some of you seem to even know the reagents for that, and well done, that's very good. And there's some other exotic ones as well, such as TPAP. I know one person mentioned that, which I was impressed with, but yeah, just oxidation. But just oxidizing up with sodium chromate is not going to work because in order to use it, you have to use water and then it's going to go to the carboxylic acid. So this would have been step 1. Step 2 is to recognize we've got the E selective, so it needs to be a stabilized ylid that we need to use. So we're going to have, this is the thing, so we got, that's the carbon, we need a phosphorus over there, so again triphenylphosphine is fine, and we want to generate that ylid. Again, a base, sodium ethoxide would have been fine. I wouldn't have used sodium hydroxide because it would have hydrolyzed the ester. If you used the phosphonate, at this stage none of you did because I haven't spoken to you about it, so that's fine, but the phosphonate esters we did in class today would have been okay. And then the last question was the elimination reaction to give a double bond, and essentially this we're going to be pulling off this proton over here with a base and we're going to form a double bond. But the important thing here is that the selectivity of the double bond, because this is an E2 reaction, it's stereo selective, and so we have to work this out with the Newman projection. I would, if it were me, I'm going to stick my eye looking down this bond over here, and then I'm going to draw out the appropriate Newman projection. The plane of the paper as I'm looking at the Newman projection is going to look something a little bit like this. Right, so I draw out my Newman projection over there. I've done this correctly. The problem is the bromine and the hydrogen they're going to leave on the opposite carbons are on the same side. So that's not going to work. We're going to need to turn this around. We need this hydrogen to get to this position over here, or this bromine to get to this position over there. However you want to do that, it's completely up to you. So when the base comes in, which is the O tertiary butoxide, the O minus picks up that proton. These electrons are going to go in to form a double bond kind of between these 2 carbons, and the bromine is going to leave like that. When that happens, we see that the double bond that forms, the ethyl and the methyl group are going to be on the same side, and the furan and the hydrogen are going to be on the same side. So if we draw our double bond, on the same side we're going to have the methyl and then the ethyl group, and the furan itself is going to be sitting over here, so you can draw it in, and that would be the correct product and would have gotten you your 4 marks for that. All right, that's it.